Dr. D here, and today we're going to learn what makes molecules polarizable, which ultimately comes down to bigger molecules are more polarizable because they have more electrons, are larger in molecular size, and an elongated shape. So let's dive into it in content with content. So when deciding if something is going to be more polarizable or not, one of the big factors we're going to be looking at is the amount of electrons. And this is kind of one of the larger factors associated with this. And the easy way to kind of figure this out is to look at the molecular weight. So if a molecule weighs a lot, it's typically going to have more electrons. So more electrons mean it's going to be more polarizable. So let's look at two examples here. Let's take a look at helium. And let's say we put in a positive charged species to help induce a dipole. It's going to move the electrons towards that positive charge. So the electrons are going to spend more time near that positive charge. So that's essentially going to induce a dipole. And if we look at neon, we have a lot more electrons. And if we have the same step where we have a charge essentially inducing a dipole, those electrons are going to migrate towards that positive end, thus inducing a dipole and giving us a partial positive and partial negative end. Now, another part of polarizability is the molecular size. So the larger the molecule, the more polarizable it is. And so as a quick kind of review, we have our periodic table, and as we go down the periodic table, we're going to increase in atomic size, and as we go from right to left, we're going to increase in atomic size. So let's bring up our two example molecules again, helium and neon. We put in a positive charge, and the electrons are going to migrate towards there, just like they did last time. But this time we're going to be looking at the actual size of the molecules. So we have a partial negative end where the electrons have migrated to, and a partial positive end. And we have the same thing for neon, but one of the things you'll realize is that these are more separated out. Our partial negative and partial positive end is much larger or much more separated than the smaller molecule. And so this is going to prevent it from interfering with our partial negative end and interacting with this positive charge. Another way we can do this is we can actually look at a molecular species. So here we have methane, CH4, and we'll be comparing that with butane, C4H10. And so, again, if we put in a positive charge, this will cause the electrons to essentially migrate towards that positive end and essentially have a trickle effect all the way down through the molecule. So a partial negative and a partial positive end. Same is true for our butane here, it's just has a little bit further to go. So I end up with partial negative and a partial positive end. And again, for our butane, our molecular size of this is just larger, or it's bigger, and it's going to spread out those charges, so it's going to be more polarizable. Then our last step for determining polarizability is to deal with the shape. So the more elongated a molecule is, the more polarizable it is. And what we mean by elongated is if we have a molecule that's essentially more balled up, or if it's more spread out. So both these molecules have the molecular formula of C4H10. The top one is 2-methylpropane, so we can kind of see that it's a little bit more scrunched up. And the bottom one is N-butane, and it's a little bit more stretched out or elongated. And so if we put in our positive charge again, it's going to pull the electron density towards that positive charge. We'll have a partial negative and partial positive end. And the same is going to happen on the bottom for N-butane. And we'll see that the N-butane has just a little bit larger area to distribute that charge and to separate out that positive and negative ends. So again, to determine polarizability, you want to look at first the number of electrons that are there. A lot of times this is done by looking at the molecular weight. You want to look at the molecular size. Larger molecules are more polarizable. And look at the shape. If the molecule is more elongated, again, kind of spreading out that positive and negative ends, it's going to be more polarizable. So that's all I have for you today. And as always, Keep thinking, and I'll see you next time. Goodbye!